In this lecture, we will study linear programming. This lecture is especially meant for class 12 ISC students, and this is the syllabus for class 12 ISC students for linear programming. Today, we will discuss these highlighted portions, and through examples, we will see mathematical formulation of linear programming problem, and in the next lecture, we will see its solution. So, today's lecture is completely based on concept. In fact, solving problem is very easy as far as linear programming is concerned, but understanding its concept is also very important, because whenever there will be change in pattern, you will be able to solve problems very easily if you have concept. So we should begin with what is the standard form for linear programming. Okay, it is maximize or minimize objective function subject to constraints. Objective function, here we are seeing objective function and constraints. We will know what is objective function and what are constraints. Maximize when it is profit, objective function will be maximized, and when it is cost, objective function will be minimized. Just for the sake of example, we can write maximize z is equal to 50x plus 8y. This is objective function, and constraints 1000x plus 1200y less than equal to 7600, 12x plus 8y less than equal to 72, x greater than equal to 0, y greater than equal to 0. This is for an illustration purpose only. Here, this is first part, maximize. This is objective function our z is equal to 50x plus 8y, and these are constraints. And these two constraints are very important. These are known as non-negative constraints. That is, the solution will always lie, suppose this is x-axis and this y-axis, it will always lie in first quadrant. This is first quadrant, this is second, this is third, and this is fourth. This constraint It is applicable for all linear programming problem x greater than equal to 0 and y greater than 0. It ensures that the solution will lie in first quadrant. What is the meaning of x is equal to 0? X is equal to 0 means y axis, and y equal to 0 means x axis. And solution will be, we will see how inequality is understood in drawing graph. So this non-negativity constraint assures that the solution will lie in the first quadrant. So we have understood the standard form for linear programming. There will be an objective function and there will be constraints, and we will have to optimize objective function. Optimize means either maximize or minimize. Okay, and this has been given to you. You can read it whenever you have time. Now there are three main components of linear programming. First one is decision variable. Second one is objective function. And third one is constraints. These are the main components of linear programming, and we must be conversant with these components. Decision variables, we will take symbol as x and y. How to identify decision variables? It is very important to identify decision variables, and at sometimes it is difficult also. So how will we identify decision variables? Identification of decision variables. Things that are in direct control of owner, manufacturer, decision makers, decision maker. He or she may be a manager. Things that are in direct control of owner or manufacturer are taken as decision variables. This is the way to identify decision variables. Okay, always remember it. Whenever you are in doubt which variable we should take as decision variable, then see from the perspective of owner that this thing is in our direct control. Next is objective function. Objective function is nothing but criterion for evaluation of solution. You have decided decision variables, how much product X should be produced and how much product Y should be produced so that profit can be optimized. So, objective function is criteria for evaluation of solution. And constraints, as we can see, an owner or manufacturer will always think in terms of infinite profit, but that is not possible because there are some limitations or restrictions in terms of capital, manpower, raw material, sometimes it may be time. These are the limitations under which any owner or manufacturer or decision maker or policy maker will work. So, these are the constraints that will need to be addressed while planning. Okay, you can read these three components here whenever you will have time. And in linear programming, we can solve different types of problems related to manufacturing problems or diet problems, etc. Now, we will find out these three components through examples. It is very important to understand these three components: decision variables, objective function, and constraints through this example. A manufacturer produces two types of steel trunks. I am translating these questions here. A manufacturer is producing two types of steel trunks, say trunk 1 and trunk 2. He has two machines A and B. He has two machines A and B. These are two machine A and machine B. The first type of trunk requires 3 hours on machine A and 3 hours on machine B. For manufacturing of this trunk, 3-hour work on machine A and 3-hour work on machine B is required. And the second type of trunk requires 3 hours on machine A and 2 hours on machine B. Second trunk requires 3 hours on machine A and 2 hours on machine B. Machines A and B can work at most for 18 hours and 15 hours per day respectively. This is maximum daily availability this is in hours. For machine A it is 18 hours and for machine B it is 15 hours. He earns a profit of rupees 30 and rupees 25 per trunks for the first type and second type respectively. Here you can write profit per trunk. For trunk 1 it is rupees 30 and for trunk 2 it is rupees 25. Whatever was in the question you have summarized here. This is the way you can always write the things. Now question comes, what could be the decision variables? Here we can see that decision variables are very clear. How many trunk of type 1 should he produce, should he make, and how much trunk of type 2 he should produce, because these are the things that are under direct control of manufacturer. So decision variables we can write x is equal to number of trunks of first type to be made, and y is equal to number of trunks of second type to be made or manufactured. Here we have very clear cut variables. We can't take machine A or machine B as decision variables because we don't have direct control over these. If you take machine A and machine B as a decision variable, you won't be able to arrive at right result. So it is very important to understand what are the things that are under direct control to achieve your objective. Okay. First thing we have done, we have found out our decision variables. Then the next thing is the manufacturer has to optimize. We will write objective function, maximize z is equal to, he has to optimize profit when he when he sells trunk 1, first type of trunk, he gets rupees 30 as a profit, and if he sells x number of trunk 1, profit will be 30x, and when he will sell trunk of type 2, that is y number, he will get profit 25y. So from both trunks he will get this amount of profit. We have to maximize this. We have to maximize z is equal to 30x plus 25y. Okay. And what are the constraints? Constraints here very clear. Just see, maximum daily availability of machine. Machine will be available only for 18 hours machine A and 15-hour machine B. So constraint is 3x plus 3y. This must be less than equal to 18 because machine maximum time that machine can be available is 18 hours, and for machine B this constraint is 3x plus 2y less than equal to 15. Apart from that, we have non-negativity constraint. X should be greater than equal to 0 and y should be greater than equal to 0. That is, number of trunk that is to be made should be greater than equal to 0. This non-negativity constraint is very important in linear programming. So we have found out the standard form of linear programming problem. We have written objective function and constraints, and the next part will be how to solve this. But right now we are learning how to formulate objective linear programming problems. Next example, we will see a mill owner buys two types of machines A and B for his mill. These are the machines. Machine occupies 1000 square meter of area. This is for machine A. Machine A, 1000, and how many men it requires? 12 men. And machine B occupies 1200 square meter of area and requires 8 men to operate. The owner has 7600 square meter of area available. Maximum availability, for area it is 7600 meter square, and for men it is 72. If machine A produces 50 units daily, daily production 50 units, and machine B produces 8 units daily, how many machines of each type should he buy to maximize the daily output? Here it is written he has to maximize the daily output. So it is very clear, decision variable is very clear here. It has been very clearly written that he has to maximize the daily output of, for that he will have to buy two types of machines, machine A and machine B. So how many machine A he will have to buy and how many machines of type B he will buy for his mill. Based on this, we can write decision variable x is equal to number of machines of type A to be bought, and y is equal to number of machines of type B to be bought, because he has to run his business. These are decision variables. We can see here for daily production he will require these two machines. So he has direct control of purchasing these machines. So our decision variable will be what number of machine of type A he has to buy or purchase and how many machines of type B he has to purchase, so as he can make daily production of 50 units from machine A and 58 and 8 units from machine B. And we can see here this area and this main, these are constraints because maximum availability is limited to the space available to the mill owner and manpower available with the. So here constraints are very clear, so you can write your decision variable very easily also. So now our task is to write objective function. Maximize, he has to maximize daily production. Z is equal to 50 into x plus 8y. We can see here machine A daily production is 50 from one machine, and if there will be x number of machine, so production from machine A will be 50x and the production from machine B will be 8y because one unit will produce 8 unit, and if he has y number of machines of type B, then total production from machine B will be 8y. These two will be added, and the objective here is to maximize this. Z is equal to 50x plus 8y. And now coming to constraints. Here we can see area and main are constant. We can write here 1000 into x plus 8 into 1000 plus 1200. Area is for second, area is 1200. Y, this should be less than equal to 7600, and for main 12x plus 8y, this should be less than equal to 72. We have, apart from that, we have non-negativity constraint x greater than equal to 0 and y greater than equal to 0. So we have written here objective function and constraints for this example. Likewise, whenever writing linear programming, we have to identify, first of all, we have to identify decision variables. And how will we identify decision variable? We have decided things we have direct control will be taken as decision variables. Then we have to write objective function, our goal. If it is profit, we will write maximize. Z is equal to, there will be linear equation, and then we will have constraints. We can write it cx plus dy. I am writing in general terms, and ex plus and always add non-negativity constant. So this way we can write standard forms of linear programming. Thus we can see that we have understood the formation of linear programming problems. In the next lecture, we will see how we can solve this type of problems. It is it is easy to solve. We will see in the next lecture. Thanks.